Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hey everybody, welcome to Wednesday night math night. I am so excited to see you all here this week. I feel like we've been on like an on again, off again, every other week kind of thing. As you can tell, I am not feeling the best again. These germs this year, I'm telling you, I legit was struggling with like pink eye and a sinus infection last week and this weekend. How do you even get pink eye and a sinus infection? I don't even know, but I did. Your girl here did. So I don't know how I managed that, but I did. So here we are. We're back. We're here for Wednesday Math Night, and just don't mind if my voice cracks on you sometimes. It just is what it is. I hope that y'all are having a great week. Like Dr. A said, I am Amy Sink, and I am one of the math specialists here at the Learning Liaisons, and I just love what we get to do here, helping you pass your certification exam. And we will do that with some problems tonight. I will go over about 10 problems, and these problems are a mixture of problems that I've come up with, problems that I've kind of like built off of different standards that I've seen on different exams, and specific requests from you. I actually had somebody tag me in our Facebook group last night and was like, hey, can you go over this week in Wednesday Night Math Night? I said, absolutely. And I added it. So that is another really cool opportunity is you can tag me on social media. You got to tag me or I won't see it at Amy Sink. And I will be happy to include that kind of stuff in the upcoming sessions. I always, if you haven't been here before, I always do a little like next week list. And so on this slide, I'm going to write next week. And if there's any topics that you want to see in the upcoming weeks, let me know in the comments tonight, and I will absolutely add them to the next week list on this slide. So before we get started, I always like to do a get to know you. So let's, in the comment box, let me know where you're from, what test are you prepping for? And have you ever seen snow? Have you ever seen snow? One of my friends got married in Colorado this weekend, and it was like they literally had a snow flurry at the end of their wedding. It was so perfect. We used to go skiing all the time. I love snow. I would live in it if I could. So have you ever seen snow? Some Floridians have not. I am from Central Florida. And there are a lot of people that I'm like surprised. They're like, I've never seen snow. And I'm like, oh my gosh, you're deprived. Like, snow is amazing. So in the comment box, where are you from? What test are you prepping for? That helps me kind of, the problems are already set, but it helps me guide our kind of side conversations. And have you ever seen snow? North Carolina, former New Yorker, you have definitely seen snow, and you are prepping for the middle school Praxis. Awesome. I have been to New York once, and I actually got my senior prom dress there when I was there. We were not there to shop for a senior prom dress. Let me just rephrase that. We were there for like a just mom and daughter, like end of high school trip. And they happened, like we passed by this boutique and they had the perfect dress. And so we brought it home. South Carolina, Praxis 5025. Awesome. Ocala, Florida. Hello, neighbor. How are you? Pre-K through 3. Awesome. And we will cover problems that are great for pre-K all the way through 12th grade tonight. And even if it's not a problem for you, please know that I often try to verbalize like, hey, even though it's a high school problem, pre-K through 3 people, you need to pay attention to this. K through 6 people, you need to pay attention to this. So I will always try to have that kind of conversation looped in when I know what tests you're taking. So that's awesome. And I'm sorry I'm not naming you by name. You guys are literally coming in on my like streaming platform as Facebook user, Facebook user, Facebook user, Facebook user. So hello, Facebook user. All right. If there are no more questions, let's go ahead and think about what you want to see me go over in the next week, and we'll get started with the first question. So, Amelia wants to fence in an area for her pets to play in her backyard. She has plotted 3 sides of the fenced area at the points A, -2, 4, B, -5, 4, and C, -7, 1. She has 18 units of fencing. What could Amelia place? Where could Amelia place point D so that she does not have to buy more fencing? All right, this is a really fun, interesting question. So, she wants to fence in an area for her pets. The first thing I'm going to do is draw a baby graph. A baby graph is just a very rough sketch of where these points are. Because if these points create a rectangle, that makes my life a lot easier than if they create some abnormal quadrilateral, right? So everybody in here, maybe not pre-K through 3, but everybody in here should know how to plot points. So even though this is probably more of a middle school, high school question, everybody needs to know how to plot points. So -2, 4. Remember, in a coordinate point, the first value is your X. The second value is your Y. How do I remember that? Well, X comes before Y in the alphabet. So that's how I remember it. And if this is my origin, which it is, positive is going to be to the right, negative is going to be to the left, just like a number line. And positive is going to be up and negative is going to be down, which makes total sense. So I'm going to just tick this off. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So -2 in the X direction. 1, 2. I'm not going to really do those humps in real life. I'm just showing you, if you don't understand the coordinate grid, how to do it. And then up 4. So I'm going over 2, up 4. If you're confused, you better say something. B is -5, 4. 1, 2, 3, 4, 5, up 4. C is negative 7, 1. 1, 2, 3, 4, 5, 6, 7, down 1. So far I have a straight line here, a diagonal line here, and I need to figure out where to put point D so that she does not have to buy. She does not have to buy more fencing. And how much fencing does she have? She has 18 units of fencing. So I can plop it at 0, 0. I could plop it at 0, negative 3. I could plop it at negative 1 up 2, or I could plop it at negative 1 down 3. None of those points are going to create a what we like to call regular or pretty quadrilateral. They're just not. So now with that understanding, I need to figure out how much fencing she has used already and then just kind of guess and check from there, right? So this distance right here is going to be pretty easy for me to figure out because for that one, I can truly just count points. So A is at negative 2 and B is at negative 5. So when I count the number of hops, not the number of tick marks, that's probably one of the most common errors people make when they're counting distances. When I count hops, 1, 2, 3, I'm going to jump 3 units to get from B to A. So this is a distance of 3. It is not 4. That is a very common error. People go 1, 2, 3, 4. It must be 4, but it's not the amount of tick marks. It's the amount of jumps. Now, how am I going to figure out the distance between B and C? How am I going to figure out the distance between B and C? Well, I have to do the distance formula. I can't equitably count the number of hops here because there are no hops, right? So to count the distance from B to C, oh my, Tammy, thank you so much. You know what? We need to erase C and we need to go negative 7, positive 1. I love when y'all catch my mistakes because I'm not perfect. So I need to go negative 7, 1, 2, 3, 4, 5, 6, 7, positive 1, and go there. That would absolutely affect my distance. Absolutely. So now that I have the accurate point, thank you, Tammy, I can now move forward with my distance formula. Distance formula equals the square root of x minus, not negative x minus x squared plus y minus y squared. Now, if you're a super nerd like me and you are super curious about where that formula comes from, it actually comes from the Pythagorean theorem. So it actually stems from the a squared plus b squared equals c squared. And when you solve it, you can get this distance formula. It's super cool, actually. So if you look up like the relationship between Pythagorean theorem and distance formula, you can see where they developed the distance formula from. So I am going to take my points negative 5, 4 and negative 7, 1 and plug them into this formula. It doesn't matter which x you put here as long as you match the appropriate y's over here. So I'm going to do distance equals the square root of, I'm going to start with this x and y. So negative 5 minus negative 7 squared plus 4 minus 1 squared. So all of that equals, my iPad just disconnected. Well aware, this happens every week. I don't know why. It's going to reconnect and then we will continue on with our distance formula. All right, so, Didn't mean to do that. Welcome to notes. I don't want notes. And now it's updating. I love that for us. All right, here we go. So -5 plus 7 squared. -5 plus 7 is going to be 2 squared. So this is going to equal the square root of 2 squared plus 3 squared. So the square root of 4 plus 9, which equals the square root of 13. Now, I'm going to use my handy dandy calculator to figure out what the square root of 13 is. If you don't know what the square root of 13 is, what you can do is figure out what the square root of 13 is in between. So I know that 9 squared is, or the square root of 9 is 3, and I know that the square root of 16 is 4. So the square root of 13 is going to be between whole number 3 and 4, right? I'm going to say that again because that is actually a test question that you will see sometimes. So this is totally random, like a side note. Side note. If I don't have a calculator or I don't have a calculator that's more than 4 functions, what I do know is I have a number line 2, 3, 4. 5, and 3 is the same thing as the square root of 9 because 3 times 3 is 9, right? And 2 is the same thing as the square root of 4 because 2 times 2 is 4. And 4 is the same thing as the square root of 16 because 4 times 4 is 16. However, if I'm looking for the value of the square root of 13, it's going to be somewhere in between 3 and 4, right? So this is the square root of 13. Now, if it's somewhere between 3 and 4, 3, let's go max. 4 plus 3 is 7. So far I've used 7 units of fencing. Now, I am going to look for the dot that is the closest. So if we replot these points, 0, 0 is right here. 0, -3 is right here. -1, 2, -1 up 2, and negative, actually I want to use a different color. And -1, -3 is down here. If I was a betting woman, which I'm not, but if I was, which of these is the safest answer choice so that she does not have to buy more fencing? Green is absolutely the safest answer choice because it's the closest. So if I didn't have enough time to solve the distance formula multiple times, I'm going to pick -1, 2 because it's the closest point that's going to create the shortest distances in this quadrilateral. I'm not going to call it a trapezoid. I'm not going to call it a square or a rectangle because it's none of those things. At least I haven't proven it to be one of those things. But what I can do is see that's close. If I were to choose pink, look at how far that distance is. So if I'm guaranteed to not have to buy more fencing, I'm definitely going to look at green. But if I wanted to prove it, I could do the distance formula between C and D, and then I could do the distance formula between A and D, and then I could add all of that up and make sure that it's less than 18. But I'm not going to do that because I know it's the shortest distance. And so what use is it to waste all of that time? We did do the distance formula once just so that you could see how to use it. But in this situation, it really isn't necessary because we can visually see it. Now, if all the points were super close to each other, you would want to do that distance formula if it was asking for more of an exact response. All right. Let's go ahead and move on to problem number 2, which was a very specifically requested problem by one of our subscribers. So This problem is just for you. Here we go. Which of the following equations is parallel to y equals 5x minus 2? Which of the following equations is parallel to y equals 5x minus 2? All right, this is actually something I've been working on with one of my high school students that I tutor, is parallel and perpendicular lines. So let's just chat real quick about parallel and perpendicular lines. So y equals mx plus b is slope, intercept, form of a line. So I know this is going to create a straight line because this is a linear function. And mathematicians are not very creative when they name stuff. So if this is slope, intercept, form, it's because I have a slope and a intercept, specifically my y-intercept, okay? And so let's shift gears to parallel and perpendicular lines. And actually, I'm going to call it parallel, perpendicular, and intersecting lines. So parallel lines never intersect. And because they never intersect, so it's lines that like go like this. They just keep going at the same slope. They are rising and running the same distance, which is why they never intersect, which means they have the same slope. Perpendicular lines intersect. They are very special intersecting lines. They intersect at a 90-degree angle. And they have negative reciprocal slopes, which means if the slope of one line is a over b, the slope of the other line is going to be negative b over a. It's going to be flipped. And intersecting lines are just lines that intersect that don't have a special relationship, right? So I don't need to write anything about that. They just are lines that have an intersection point that don't fall under perpendicular or parallel. So if parallel lines have the same slope, and this is my equation, what is the slope of that equation? The slope of that equation is 5. Why? Because it's in slope-intercept form, and the m represents the slope, and so the 5 is the slope. All that said, what do you notice about every single one? What do you notice about every single one of these equations? None of them are in slope-intercept form. None of them are in point-slope form. They're all in standard-ish form, if you will. They're not really standard form, but they're not in a form that's helpful, right? And so in order to figure out if they are parallel, I have to seek out if they have the same slope. And so that said, I'm going to have to go equation by equation by equation to see what the slope of those lines are. So let's go ahead and do that. Let's take, and I'm going to use different colors to delineate. Let's take this equation right here. Negative 10 equals 5y plus 5x. Zoom. How do I get it into slope-intercept form? Well, let's zoom out and look at what is critical about slope-intercept form. It's a y equals equation. So I need to isolate this y by itself. So how do I isolate the y? Subtract 5x from both sides is where I'm going to start. So I have negative 5x minus 10 equals 5y. Now, what if you're like, wait a minute, Amy, this is not going to work for my brain. I needed you to add the 10 to both sides and then subtract the 5 to both sides and then do all of that because I need my y on the left. Sure, that's fine. We're still going to get the same answer. You're going to have different negatives and different positives, but by the time we divide it all out, you'll get the same answer. So it doesn't matter. But remember, an equation means it's a balance. It's the same as. So if I can get y by itself over here, whatever is over here is going to be the same no matter what side of the equation it's on. So all of that said, I'm now going to divide both sides by 5. But I'm going to divide everything by 5. And I get y equals negative 5 divided by 5 is negative 1x. Negative 10 divided by 5 is negative 2. Did I really need to go that far? No. All I needed was this piece right here because that's the slope. And negative 1 is not the slope I'm looking for. So those are just going to be normal intersecting lines. All right, let's look at this equation. 4 equals 20y plus 4x. Remember, we're trying to isolate y to find a slope of 5. Zoom it in. How do I get y by itself? I'm going to do this one the opposite way of what I did this one, and I got my y on the right. Some of you are like, Amy, no way. I need my y on the left. Well, let's do the y on the left this time. Same process, just a little bit more steps. I am going to subtract 20y to both sides. So I have negative 20y plus 4 equals 4x because that's what's left on that side. Now I'm going to subtract 4 from both sides. Negative 20y equals 4x minus 4. Divide everything by negative 20. And we get y equals 4 divided by negative 20. Some of you are looking at that like, whoa, I don't do that. That's a fraction. Fractions are not scary. They're just numbers. So I'm going to get 4 over negative 20, but I know I can simplify that. How am I going to simplify that? Well, I know the top can be divided by 4 and the bottom can be divided by 4. So 4 divided by 4 is 1. 20 divided by 4 is negative 5x. And this is going to be the same thing, 1 over 5. Is that the same thing as 5? It is not. However, I want you to look at that specific relationship. What do you notice about the slope of that line? What is the slope of that line? Negative 1/5. What does that mean? What does that mean? That means that those lines are perpendicular. You're absolutely right. So these lines were intersecting. And these lines are perpendicular. Great job. Now, my brain tells me, wait a minute. This kind of looks like this. And this one, I just got like the upside down version of 5. So I wonder if this one would give me the right side up version of 5. I wonder if it would give me the reciprocal. I'm going to try that first. So rather than doing C next, I'm going to jump to D. And this is where a good test taking strategy comes in, because you need to be able to look at your answer choices quickly, and that will save you time. Because do you see how much time this problem is taking? So if I can see that pretty quickly, it's going to allow me to save myself time. Let's go ahead and write this problem out. Negative 20 equals 4y minus 20x. Zoom in. Let's solve it. I'm going to add 20x to both sides just because I don't mind the y being on the right side of my equation, and it's less steps. So add 20x to both sides. That does not equal 0 because that 20 does not have an x attached to it. So this becomes 20x minus 20 equals 4y. It is not 0x or negative 1. You cannot add things together that are not like terms. Now I'm going to divide everything by 4, divide by 4, divide by 4. 20 divided by 4 is 5. Look at that. We found our slope of 5. So that means that this line is indeed parallel, which means D is our answer. Those were some fun problems, weren't they? All right, let's go ahead and move on to the next problem. Find the slope of the line tangent to the vertex of y equals negative 3x squared plus 6x minus 13. I always love doing problems like this. So, where are my high school people at? This one's for you. You know what? I'm gonna go like this because we're gonna get real close. I want you to think, before I start solving this problem, what shape that creates. What shape does this function create? What shape is this? An upside down parabola. My elementary people, you can check out for just 1 minute. There is nothing about this problem that you need to know. We'll get to another one, I promise. So if I do a baby graph, it does not matter where I put it. It doesn't matter if it's here or here or here or here or here. It does not matter, because here's why. Vertex. There's a vertex. There's a vertex. There's a vertex. And we're looking for the slope of the line tangent. Tangent means it hits that point and that's it. It slices through just one point. What is the slope of all of those lines? What is the slope of all of those lines? Zero. Now, this is a problem that a lot of us would have gone, I have no idea how to do that. That's calculus. You have to find the derivative to do that. I don't know how to do that. Blah, 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 blah. But if we just visualize it, if we just draw a quick pic, if we take a second to realize what it's asking, sometimes we can fumble our way through it. Now, if it asked for the slope of the line tangent to the point 3,7, and I had to figure out what the slope of the line tangent to that is, then yeah, we would have to use a little bit of calculus to figure all of that out. But they didn't ask for that. They asked for the vertex. No matter where the vertex is, no matter what kind of parabola it is, even if it was a right side up parabola, the slope of the line tangent to that vertex would be 0, too. So don't overthink problems that don't deserve to be overthought. Does that make sense? All right, let's move on to problem number 4. That was a pretty easy problem, wasn't it? Don't forget that we have a next week running right here. So if you have any questions or content that you want to see me go over in the upcoming weeks, let me know. I'm going to start my bullet points now so that I can start thinking about what we can add to this so that you can see what you need to see before your upcoming test. All right, let's go ahead and look at this one. This is a really, really fun one. Amelia makes blankets. She can make 8 blankets with 32 yards of material. How many yards of material would be required to make 22 blankets? How many yards of material would be required to make 22 blankets? So word problems. That's funny because here's a word problem for you, right? I read your mind. I just pulled this problem out of nowhere. Not true. Is there any specific kind of word problems you want to see? I will absolutely include that in my next week, but any specific content you want to see, multi-step, word problems for elementary, what kind of word problems? All right, so she's making blankets and she can make 8 blankets with 32 yards of material. How many yards for 22 blankets? So this problem specifically is pretty straightforward. If I have 8 blankets, 1, 2, 3, 4, 5, 6, 7, 8, and I have 32 yards of material, how many yards would go into each blanket? That's division right there. That's 3rd grade division right there, right? How many yards? 4 each. Because 32 divided by 8 equals 4. However, if they were not equitably divisible, so if it was 8 blankets with 30 yards of material, then the process would be a little different. And we would be going from a elementary level problem to a middle school and high school level problem. So right now, this right here is an elementary problem. But the minute it goes from 8 blankets with 32 to 8 blankets with 29 yards, we've now turned it into a middle school and high school problem. Because now I have to use proportions and cross multiplication, okay? But we don't have to do that. How many yards of material would be required to make 22 blankets? Not 22 extra blankets, 22 blankets total. So I need to do 22 blankets times 4 yards of material equals 88. Doubling and tripling exponential. Not entirely sure what you mean by that. I will write it down. Doubling and tripling exponential functions. So 3 to the x power tripled. I'm not entirely sure what you mean by that. If you have a picture or an example, let me know. All right, questions about that problem? All right, a triangle has points A, -3, 2, B, -1, 1, and C, -2, 6. If the shape is rotated 90 degrees counterclockwise about the origin, what would the coordinates of A prime B? This is an interesting question too. So this is one of those questions that some people can visualize and some people have to memorize. The more you do Math Wednesdays and my boot camps and stuff, you will very quickly realize I am not a proponent of memorization. I'm just not. I don't like telling you to memorize stuff. It's not my style because we don't have enough space in our brain as it is. That said, this is something I've memorized because my brain does not take rotations very easily. Now, I will say there's all sorts of things that you can memorize for reflections and for translations. I don't memorize any of that. I can visualize a reflection. I cannot visualize a rotation. So let's plot these points really quickly. If you've memorized the rule, you don't even need to plot the points, and I'll show you why in a minute. But I'm going to plot them just for kicks and giggles. -3, +2. -1, +1, and -2, +1, 2, 3, 4, 5, 6. So if it said reflect this over the x-axis, reflect this over the y-axis, I can do that all day long without memorizing something. Because if I'm reflecting it over the x-axis, I'm just figuring out how far away is this from the x-axis. And then I'm going to do the same right here, and it's going to be right on top of each other. And this is 6 away, so this is going to be 6 away too. And this is 2 away, so it's going to be 2 away right on top of one another, and there's my reflection. Like, reflections are easy without memorization. But that rotation, y'all, can't do it. So I always have memorized it. So your rotation rules. And we're going to do original, and then we're going to say rotate 90 degrees counterclockwise. Rotate 90 degrees clockwise. And that turns into, if I'm rotating 90 degrees counterclockwise, -y, x. If I'm rotating 90 degrees clockwise, that turns into y, -x. Again, I can't visualize this, so I just memorize it. So if my question is asking me, what would the coordinates of A prime be? A prime is just the next image that happens. I need to take the A point, -3, 2. We're going 90 degrees counterclockwise. It becomes -y, x. So -y is first. -2, normal x. D is my answer. Now, if it was -x, y -x, it would be 2, but the x is already negative. So if I was doing a negative x, I would be doing a negative times -3, which would give me a +3. Does that make sense? So you want to be careful with those double negatives creating that positive. Let's take a look at another rotation problem so that you can see how it works. A triangle has the exact same points. So let's go ahead and take our picture and copy it right on over. And let's take our rules. And copy those right over. Now, there are also rules for rotating 180 degrees, 270 degrees, but these two problems are 90 degrees, so that's where I'm living. However, if you wanted to know what is the rule for 180 degrees, what is the rule for 270 degrees, you can literally Google rotation rules and it'll spit out a chart for you that you can see. So, triangle has the same points. If the shape is rotated 90 degrees, I see what we're doing. 90 degrees counterclockwise, clockwise, not around 0, 0, but 90 degrees counterclockwise around a point. How does that change what we're doing or our behavior? That's a great question. So that 90-degree rotation is still playing a factor in it. Like that rule still exists. However, you then have to subtract and add the point back in. So that 90-degree counterclockwise rotation is still negative y comma x. However, we have to subtract the point, rotate it around the origin, and then add the point back in. So let's go ahead and see what that looks like. So my point is negative 3 comma 2. But I need to subtract this point out of it. So I'm going to do negative 3 minus negative 2 and 2 minus 2. Negative 3 minus negative 2 becomes a positive. So negative 3 plus 2 is negative 1. 2 minus 2 is 0. I'm now going to rotate that 90 degrees counterclockwise. So then that becomes y negative x. No, negative y x. So negative 0, which is just 0, comma negative 1. And now I'm going to add this back in. So 0 plus negative 2 and negative 1 plus 2. So 0 plus negative 2 equals negative 2. And negative 1 plus 2 is positive 1. And that's not an answer choice. I think I did something wrong. So we're going to star this problem. Sometimes I just don't have the right answer, but I'm going to star this problem and come back to it because clockwise around the origin, you just have to follow those rules. But clockwise around a point, I feel like I'm missing a step. And so I don't want to lead you wrong. So problem number 7, we're going to come back to next week. Sound good? All right, let's go ahead and do greatest common factor to close us out tonight. Now, as you're sitting there thinking, you got to let me know exponential functions. So far, I've heard from my high school people what they want to see next week. Pre-K through 3, K through 6 people, what do you want to see? Otherwise, we're going to be doing a lot of exponential functions and doubling and tripling. And you may be like, whoa, Amy, that's not helpful. Let me know in the comment box what you want to see. All right, let's chat about greatest common factor, least common multiple, because it's one of the main things people get confused. So, what is the greatest common factor of 18 and 24? So here's the thing. Greatest common factor and least common multiple are very often mistaken. What is a factor? And what is a multiple? A factor is like a part of a number. A factor is like a part or a divisor of a number. So the factors of 18 are going to be 1 and 18, 2 and 9, 3 and 6, 4 times nothing is 18, 5 times nothing, and then 6 times 3, I'm back. So the factors of 18, like when you think of a factor tree is when you do like 2 and 9 and then 3 and 3. Factors are things that multiply to get me another number. So the factors of 24 are going to be 1 and 24, 2 and 12, 3 and 8, 4 and 6, 5 and nothing, 6 and 4. So I've looped back around. The multiples of 18 are 18, 36. So it's 18 times 1, 18 times 2, 18 times 3 is 54. 18 times 4 is 72. The multiples of 24 are 24, 48, 72. So and that's going to literally go on for infinity, whereas there are not an infinite number of factors. When I see the word greatest, I'm thinking the largest possible factor that is common between them. So when I circle all of the common factors, 1 is the same, 2 is the same, 3 is the same, 18, nope, 9, nope, 6, yes, 6 is the winner. When I look at these answer choices, I can almost immediately cross off 72 when I see this, because I know that the greatest common factor is not going to be bigger than the numbers I'm given. Whereas if it asked for least common multiple, I can cross off anything that is smaller than the two numbers that's been given to me, because a multiple is going to be things that, like, that times 1, that times 2, that number times 3, that number times 4. And so the number can't be smaller than the original number. So 72 would be the least common multiple because it is the smallest common multiple that we have. But people confuse the two all the time. All right. We do not have time for any more problems tonight. So in the comment box, let me know what you want to see me go over next week. That was a super fun session. Look at all these problems that we did together. We did so many problems tonight. So in the comment box, let me know what you want to see me go over in the upcoming weeks. I know that there are lots of people preparing for spring break. Spring breaks are coming up. I feel like March and April is like the months of spring break. So if your spring break is coming up, or your kid's spring break is coming up, or you wish spring break was coming up, happy spring break months, because we are officially in March. And I will see you all next week. Like I said, I'll hang out for a couple minutes. I'm going to turn it back over to Dr. A to close us out. But let me know. I'll hang out and see if there's any comments about the upcoming week, and I will see you all next week. Have a wonderful week.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SYNC35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.